This is the video tutorial for homework 4 assigned to the people in lab section 51. Now, the difference between the assignment in lab 51 and lab 52 is that people in this section 51 are supposed to submit problem number 1, and people in lab number 52 are expected to submit a different problem number 2. Okay. That being the case, for this lab 51, I'll do problem 1. I won't do problem 2, but the video for lab 52 is going to be doing problem number 2. Okay, so the people in this section, if they want to see how the second problem is done, you should go to the video for the other lab section, namely 52, and the other way around. Okay, the problem that we are doing definitely is an assembly. You have to use solid elements. Okay, solid elements. There is basically this disk, and there are these 3 pins which are symmetrically inserted into that. And the top pin is clamped at both ends, and the same thing with the bottom pin. And the middle one is subjected to a displacement of 0.004 inches along the x direction. You're supposed to use all planes of symmetry. Now, if you look at this problem, stare at it for a while, you'll see that XZ is a plane of symmetry. In other words, you can do the left side or the right side of this. And XY is also a plane of symmetry. Now, there are different ways of doing these problems. You can create the entire thing and then cut it with different planes, okay? Or you can model only the top half. It's up to you how you want to do that. So I will make the whole thing, and then I will cut it with the planes. As a matter of fact, there is really no need to do 3 pins. All you need to do is 1. As long as you're careful and you do it properly, you can use this as basically a copy of it, okay? Or you can literally go and make 3 of them, or literally go make 2 of them, because the third one is going to go away anyways. This is the strategy that I'm going to take. I'm going to make the disc, okay, the disc and 2 pins. The third one I'm not going to make because eventually I'm going to cut it, and therefore there's no need to do the bottom one. Okay. All right, so let's go ahead and start this. Start with the product file. Remember, this is an assembly, and the way I discussed it in class, I make the parts on the fly in the product design. Let me immediately save this thing. File, save management, save as. I already created a folder on my desktop. I already created a folder called homework 4, lab 51, problem 1. I'm going to give this thing a meaningful name. So I'll call it your student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9 dash. We call it Euler. How about that? Euler. And this is homework 4, problem 1. Lab 51. Okay. No problem. Okay. We say, all right. Now I'm going to insert the new part in there. And I'm going to call the name of this thing disk. Properties. Where's that properties? I'm going to call it disk. And disk. Make the disk. Double click on disk. On a convenient plane, on that vertical plane, I will sketch a circle of radius radius 12. Okay, that's it right there. Draw two circles. One over there. This is where the middle pin is going to go. And let me dimension this thing. Radius is 1, I believe. Yeah. And then I'm going to make another circle up here. Also radius 1. And 6 inches apart. These are 6 inches apart based on the drawing that I have in the homework statement. 6. Now, I'm not going to bother making the bottom hole, okay, bottom circle here, because eventually the bottom thing is going to disappear anyways. So we're going to pad this thing in each direction, 1 inch. I think the thickness of that disc was 2 inches. Okay. Look, I'm not making the bottom one. I understand that. Okay, don't let it bother you. Okay. Now, then I'm going to insert my next part. Insert a new part in there. And I'm going to call this thing middle pin. How about that? Right click, properties, middle pin. And the part name is middle pin. Okay. Let's make it. On a convenient plane, on that vertical plane, I'll do the sketch. But why don't I project that circle instead of sketching a circle and padding it? So let me project that circle. Just this circle. There we are. Exit. And then pad it in both directions by a total of 6 inches. So 3 inches in each direction. So this is the middle pin. Okay. Now let's make the other one. There are ways that you can use this to proceed with the rest of the problem, but literally I'm going to make the top pin. That idea. Insert, new part, in there. Let's call this thing top pin. Properties, top pin. And top pin. This is the part name, the top one. This guy is the instance name. Okay, very good. Double click on it. On a convenient plane, on that vertical plane once again, on that YZ plane, I will sketch. Okay, project that circle. Exit, pad it in both directions, just like before, but 3 inches. Okay, there we are. Now I want to point out to you that there are no assembly constraints at this point. If there is any possibility that you may want to move these things apart, if there's any chance you want to do this thing, move these apart, I suggest you put assembly constraints on it. Okay? I don't intend to do that. Therefore, I created them in place, just like it is. And I have no intention of moving it apart, so I'm not going to put assembly constraints. Bad idea, because you never know what happens down the road. Okay, so the first thing I'm going to do, we're going to split this thing. Okay, now you can go to the individual parts. For example, go to the disk and split it in the middle and split it like that, and then do the same thing with this pin. Split in the middle, split it like that. You go to the top part, split in the middle. But the alternative is to use this saw, the split in the assembly. See, we are in the assembly. There's a split there. And it's going to ask you, the bottom left corner, select a plane to cut it. So if I use, for example, this, it's going to say, hey, look, when you cut this thing with that plane, these are the parts that are going to be affected. Would you like to take all of them? The answer is yes. See that? We just selected this guy. Everything went down. And we say, okay, there we are. Okay. And then again, another split with that middle plane. It says, hey, you know what? When you cut it, these are all affected. Are you sure? The answer is yes. And we say, okay, and there we are. So we have half of the thing, actually a quarter of the thing as we wanted. Okay, let's make everything out of steel. Again, I emphasize I did not put any assembly constraints, so hopefully I will not have to move any of these. Now, we're going to save this. And to save it, all you do is you notice that I did not save the individual these disks. I didn't do that. Okay, the disk or the. But if I go to the top level, right there, top level assembly, and click on the floppy, it will not only overwrite the product, but it will save the disks for you, okay, or the parts for you. Okay, so if you go, for example, to your folder, you see that the part was the product is here, and there are three parts there, all saved. Okay, very good. Now let's make everything. This is done. So now we're going to go to generative structure analysis, just like before. CATIA sees three parts. It sees the disk, it sees the top pin, the middle pin, and it's going to mesh it for you. The only thing is that if on the test we say use the default element size, okay, just leave it the way it is. However, right now I want to change this uh, these elements. Okay, so this is for the disk. I'm going to make it smaller. I don't know, maybe 0.3. Still use parabolic. These two, I'm going to keep it the way it is. That's all right. Okay. Uh, this is it. If you want to look at your mesh, right click, mesh visualization, just like before. That's a lot of elements, a lot of nodes, because you can see it's taking, taking its time. So I'm going to change some of those sizes so that they're a little bit bigger, so that it doesn't take as long. This tells you that we have a fine mesh, and there's a lot of them. That's why it's taking long. And I hope there we are. You see that? Oh, what happened here? Just a second. I have two choices. I can make the elements linear. It's going to be a lot faster, or I can make the size of the parabolic ones bigger. I hope this did not crash. Yeah, we see that? It's unnecessarily too big. So here's what I'm going to do. Uh, okay, bear with me for a second. That's a lot of elements and nodes. Not responding. I think this has gone into coma, as you can see. So this is a good reason that you saved. So let's see if we can kill this job, because I'm sure that this has gone into some kind of a loop. And I kept telling you that save before you do the next step. You can see why. So the only solution that I have here is yeah. Let's give it a one more minute. See what happens. I think time to kill it. So let's do Control Z. Let me see for a second. Yeah, Control Z, definitely. Okay. So be prepared for stuff like this. So I'm starting CATIA. I'm going to bring my product. Remember, I did not save my analysis because it didn't actually get to that point. It crashed while it was trying to mesh. So I'm starting CATIA. I bring in my product, which I saved. Do you want to recover? No, I don't want to recover. Very good. Close that. Let's bring that thing into the. Let me close this. File. Where is the product? It was right here. Right there. Okay. So what we're going to do is we're going to go to generative structure analysis, and I learned my lesson. Okay. So you go here, double click on this. Let me change this thing to 0.5. Okay, fine. However, I'm going to use linear. Okay. And I'm going to double click on this pin, make it linear. I keep the sides same. And you can see why on test we might say, oops, not this one, linear, we might say keep the default size and element type. So, or use linear. We're going to say use linear, for example. Let's look at it now. Right click. Remember, it crashed last time. All I did was to change the elements from quadratic to linear. Okay. All right. Now we can save our analysis. File, save management. Here's the analysis. Save as. In that folder, what was the name? Your student ID number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dash your last name is Euler. Dash all the stuff that I had there. Homework 4. What is that? Underscore problem 1. Lab 51. Okay, and then there's analysis. Fine. Okay, good. I still would like to make these things bigger, but just because it's linear, it's going to be okay. Right click, deactivate. Let's do the rest of the problem. Okay. Because we use symmetry, this big disk, that little cross section of the pin, and this little cross section of the pin, they're on surface slider, and the bottom, and the bottom. Surface slider here, and there, and there. Okay, that takes care of this. We know this top point, top left end of the pin is clamped. Okay. We know that this is supposed to go in in this case the y direction, in this direction, not the x, because I did the drawing different from the coordinate system that I showed in the homework problem. So in this direction. Okay. So first we make it 0, just like before. That face, we make it 0 in the direction y. Rotations don't matter because this is a solid element. Okay. And now we can change that. We go here, you click on enforce displacement on this thing that you just defined. We're going to change it to 0.004, I think that's what it was. 0.04. Very good. Now, if I run it, it's going to bomb out because the disk does not see the pins. Just to show you what happens, I'm going to say fine. I'm going to run it. You see that it's going to bomb out because there's nothing. Don't worry about that. There. So because the pin doesn't know there's a disk there and goes through it. So you can see what happens. See this? So you have to create the interaction between the pin and the disk. You should say you cannot penetrate that disk. Okay, cancel that. Deactivate this last block. Okay, very good. So we create connections. For example, surface of the pin cannot penetrate the surface of the hole. That means you create a connection. These are the connections, analysis connection. We have done these in class, okay? So the surface of the pin, for the second component, hide the pin, take the surface of the hole. We created one connection here, and we repeat the same thing up there. So another connection between surface of this pin, hide it. For the second component, the surface of this hole, we say, okay, we created two connections here, right there. You can see that. Maybe I should have given these names. For example, this is the top pin, this is the bottom pin, but it really doesn't matter in this particular problem. It's simple enough. Now, we declare these connections as contact. So look for right there, you can see that. Connection properties. The first one is face-to-face connection properties. Let me move this thing down here so you can see it. Face-face connection properties, and look for contact. Contact, right there. Right there. Click on it. We select this thing to be contact. Excuse me. And again, this thing to be contact. Notice that, cancel, no, not that one. Again, this one, the second one. See that it puts the contact icon there. Put the contact icon there. Don't worry about all those default settings there. Just leave them the way they are, and save it and run. This time it will run once you pray. Yep. So look at the deformation. If you can't see anything, just set the default scale right there. You can see what happens. Let's animate this thing. Notice that where is this animation? Right there. You can see that when this thing moves, it takes the discs with it. It doesn't penetrate it. It takes it with it, and this kind of stops it around there. If you look at the deflection, obviously most of the deflection is due to movement of that pin. That should be obvious because this is very stiff. There we are. As you see, most of the deflection is because of the movement of the pin. Okay, this doesn't budge a lot. And then you can look at the 1 meter stress. Because the pin is bending, basically most of the stress is in the pin. Very little stress here because it doesn't move that much. Okay, and that's pretty much it. So let me save this thing, and this is for lab section 51. The second problem, which is going to be the one that people in 52 have to submit, I'm going to do it on the other video. So I'm going to stop this thing. If you want to see the problem number 2, go to the video for section 52. Okay? Good luck.